an is 3 times an minus 1 plus 2. If you are reading this in words, an means nth term or any term. 3 times an minus 1. An minus 1 means the previous term. If n is 10, an 10, 10 minus 1 means a9. That means an minus 1 is the previous term of an. Similarly, an plus 1 will be the next term of an. So previous term, next term. Previous term means an minus 1. So the meaning of this one is any term is 3 times its previous term plus 2. That means to get any term, take the previous term and add 2, we get 3 times previous term. Take 3 times previous term plus 2, we get this term. Again, to get the next term, 3 times this term plus 2. So any term is obtained by adding 2 to 3 times previous term. That's mean. For all n greater than 1 means if second term onwards. So second term onwards, this one. The question is to write the first 5 terms. So A1 is 3. A2, by this definition, 3 times n minus 1 means previous term, n minus 1. Here n minus 1 is 2 minus 1. That is 1. That is A1. See that if it is A10 here, this will be A9, the previous term. For any term, n minus 1 means previous term. Don't waste time writing 2 minus 1, directly A1. Plus 2. This means 3 times what is A1? 3 plus 2, which is 9 plus 2, 11. So A2 is 11. We got A2 of 11. Now, A3. See that A3 is 3 times previous term. Which is the previous term of A3? The previous term of A3 is A2. So 3 times A2, 3 times A2 plus 2. That is 3 times, what was our A2? A2 is 11 plus 2. 33 plus 2, we got it as 35. A4. See definition? A4 means 3 times the previous term. 3 times previous term of A4 is A3 plus 2. 3 times A3 is 35 plus 2. 35 is 105, which is 107. 107. Then is, what is it, Hadi mom? Hadi, what is your problem, Hadi? Yes, no problem. Then A5. Three times previous term, A4 plus 2. See that 3 times n minus 1 means an minus 1 stand for the previous term. This is 3 times 107 plus 2. So 321 plus 2, 320. So these are the 5 terms. A1, A2, A3, A4, A5. Now, the question is to write also the corresponding series. Corresponding series means you don't have this infinite one. So it is 3 plus 11 plus 35, 107, 323 plus etc. It goes on because n means for n greater than 1. It is infinite series. That is the corresponding series. Now we will do question number 13. 12th one exactly same. Try to say homework. Come to question number 13. See question number 13. I hope you have completed. Question number 13. 12th one is same. One, A1 is equal to A2, A1, A2 is equal to 2. N is N minus 1 where N greater than 2. What does this mean? Again, write the first 5 terms, then the corresponding series. N, any term is N minus 1 means previous term. Previous term minus 1. That too starting from where? N greater than 2 means after second term. That means third term onwards. In this sequence of numbers, N greater than 2 means after 2. That means third. After 2 it is the third term. Third term onwards, any term is previous term minus 1. Third term onwards. Why third term onwards? Because the first 2 terms are given. So A1. A1 is 2. A2, that's also 2 because it is given. A3, third term onwards. What is the definition? N minus 1 means A3 minus 1, A2, previous term. Minus 1. That is A2 is 2 minus 1, that is 1. Then A4. Previous term. A3 minus 1. A3 is 1. 1 minus 1, 0. Write the previous 2 term. Then write the next 2 term. Next term, A5. Then write a series. In the meantime, I will take the attendance. No problem. If they are interested, let them come. It is not compulsory that you have to attend classes. Yeah, a lot of absences are there. So A plus etc. Hamza plus etc. Your series it goes on. A5. A4 minus 1. A4 minus 1. 0 minus 1. That is minus 1. So corresponding series 2 plus 2 plus 1 plus 0 plus minus 1 plus etc. Plus etc. Now come to question number 14. But don't need of no need of simplification. Write that series, that's all, because it goes to infinity. It goes to infinity. So write that series. Now, question number 14. See the Fibonacci series. It is question number 14. Question number 14. Fibonacci sequence. 1 is equal to A1 is equal to A2. 1 is equal to and an is an minus 1 an minus 1 plus an minus 2 for n greater than 2. The question is to find n plus 1 by an for n is equal to 1, 2, 3, 4, 5. N plus 1 by n is equal to 1, 2, 3, 4, 5. So 1 is equal to A1 is equal to A2. An is an minus 1 plus an minus 2 for n greater than 2. N greater than 2. See here, 1 is equal to A1 is equal to A2 means A1 first term, second term. First term, second term are 1 each. After second term, if n is greater than 2, third term onwards. Third term onwards, any term. How will you read this in words? An is an minus 1 plus an minus 2 means any term. If this is the nth term, n minus 1 means its previous term. N minus 2 means its previous term. That means sum of the previous two terms. This means sum of previous two terms. So to find any term means sum of the previous two terms. That's meaning of it. By this definition, to find the 10th term, what to do? The 10th term will be A9 plus A8. 10th term will be A9 plus A8, previous two terms. So to get the 25th term, take the previous two terms. 25th term, the previous two terms are 24th and 23rd. So A24 plus A23. That is this definition. An is an minus 1 plus an minus 2 means to get any term, we add all sum of the previous two terms. N minus 1 is the previous term. N minus 2 means again the previous term. Previous two terms. Our aim is to find n plus 1 by an for n 1 to 5. If n is last step, if n is 5, we need a5 plus 1. That means a6. a6 by a5. That means we need a1, a2, a3, a4, a5 and a6. Because n plus 1, if n is 5, n plus 1 is a6. So first we will find terms a1, a2, a3, a4, a5, a6. Then we will find this expression. So a1 it is given as 1. a2 is also given as 1. a3 by definition it is a2 plus a1. Sum of previous two terms. An is an minus 1 plus an minus 2 means sum of previous two terms. So a2 plus a1. What is a2? 1 plus a1, 1. That is 2. a4. a4 is sum of the previous two terms. The previous two terms are a3 and a2. a3 is 2, a2 is 1, that is 3. a5, previous two terms. Write the previous two terms. Previous two terms means A4 plus A3. What is A4? 3, A3, 2, 5. A6. How many is A6? The previous two terms. A5 plus A4. 5 plus 3, 8. In this question, it is not asked to find the first 5 terms. In the previous questions, the question was to write the first 5 terms of the sequence. Here, the question is not to write first 5 terms or anything. Then, why did we find this first 6 terms? Why did we find A1, A2, A3, A4, A5 up to A6? Why? Why not A7? Or only why till A5? How many of you got the idea? Why only up to A6? The reason is the question is we need to evaluate this one. The question is to find the value of this expression. Find the value of this expression. In this expression, we have to find n up to 5. If n is up to 5, the numerator a n plus 1 becomes a5 plus 1, which is a6. That means we need the 6th term of the sequence. That is why we found up to a6. Now we will find this one. Or the question is to find this one. So if n is 1, an plus 1 by an becomes a2 by a1. Is it? If n is 1, an plus 1 becomes a1 plus 1. a2 by a1. And what was a2? a2, 1 by 1. That is 1. Now if n is 2, our expression will be n plus 1 by n becomes a2 plus 1, a3 by a2. If n is 2, 2 plus 1 is 3, a3. a3 by a2. And what is a3 by a2? A3? 2. 2 by 1, that is 2. Now, if n is 3, our n plus 1 by n becomes, if n is 3, 3 plus 1, 4. a4 by a3. a4, the fourth term, 3 by a3 is 2. Cannot be further. Give it a fraction. 3 by 2. Next one. N is 4. Our expression n plus 1 by n becomes a4 plus 1, a5 by a4. What is a5? 5. By a4 is 3, 5 by 3. If n is 5, our expression an plus 1 by n becomes a5 plus 1, a6 by f3. We need a6. That is why we found a6 earlier, which is a by 5. That's it. Now, I hope you have completed. Now we will start God. The next topic, which is arithmetic progression, AP. See, AP or arithmetic progression, you learned it last year in class 10. So this AP is a special type of sequence. Arithmetic progression, AP. You know what an AP is? AP is a sequence of numbers in which, except the first term, all the terms we get by adding a fixed number. See, for example, 5, 7, 9, etc. 10, 13, 16, etc. Minus 20, minus 15, minus 10, etc. These are all examples of AP. You learned it last year, AP. So here, what's the speciality of the sequence of numbers? If we keep on adding 2, we get the next number. Keep on adding 3, we get the next number. Keep on adding 5. Similarly, 10, 8, 6, etc. Keep on adding minus 2. Keep on adding minus 2. So these are AP. In AP, you can see that to get the next term, we keep on adding a fixed number. This fixed number is called the common difference. You learned it. Right definition. AP is a sequence of numbers. AP or arithmetic progression. AP is a sequence of numbers. AP is a sequence of numbers in which AP is a sequence of numbers in which all the terms in bracket except the first term. AP is a sequence of numbers in which all the terms except the first term is obtained by adding a fixed number to the previous term. So AP is a sequence of numbers in which all the terms except the first term are obtained by adding a fixed number to the previous term. Next line. The fixed number added is called the common difference. The fixed number added is called the common difference, denoted as D. The fixed number added is the common difference, denoted as D. First term denoted as A1 or A only. Now we will write the formula. This formula also you learned last year. AN, the nth term. AN is A plus N minus 1 into D. You know how we are getting this formula. AN is A plus N minus 1 into D. Yes, okay, here from this one. See, this is a new formula. N is equal to An minus A1 by D. This you can give it as for finding number of terms. For finding the number of terms of an AP, this formula can be directly used. Actually, last year you learned it to find the number of terms of an AP. To find number of terms of an AP, we substitute this only. To find D, this is B. Denominator is B. See, actually this formula is derived from this one. How? To get D, see that n minus 1 into D is An minus A1. A means A1 only. Is it? If you are taking D to the other side, n minus 1 will be An minus A1 by D. If you are taking minus 1 to the other side, n is equal to An minus A1 by D. This minus 1 to the other side plus 1. So actually this formula is derived from this one. Even if you are substituting this formula also, we get the value of n, number of terms, but we can use this directly. N, this number of terms. So to find number of terms, we can use this formula directly, or this is no problem. This is better. Then the formula for SL you learned last year, n by 2, 2a plus n minus 1 into d. Also, we can use n by 2, a1 plus a. Again, the significance of these two. These are same formulas only. Why? Because this a can be replaced, 2a can be replaced a plus a. 2a can be replaced a plus a. So if you are writing this as a plus a, if I am writing this as a plus a, now see this a plus n minus 1 into d, that is a. One a is left, that is a1. So it is same thing only. When do we use this one? If last term is known, we prefer this. If last term is known, we prefer this. If last term is not known and common difference is known, we prefer this one. Both formulas will give the same answer. That is just it. Again, these formulas you learned last year. And formula for Fn is an interesting one. You know, it was given in your last year's textbook, maths textbook. I don't know how many of you might have gone through it. How many of you know that story? This one is invented by a mathematician. Anyone, do you know his name? This formula is invented by a mathematician. No one knows. In your class, not Shakuntala Devi. Shakuntala Devi is different. This one is invented by a mathematician called Gauss. Then you may ask, what is specialty? The specialty in it is, when he was at the age of 10, that means when he was a class 4 or 5 student, he invented this formula. How? I think you know the story. How many of you knows? Gauss invented. Okay, see, this is the thing. Actually, sometimes this happens when we come to school. Yes, Amar, you know it. Sometimes when we come to school, there will be some clerical, our headmaster may give some clerical work. See, for example, especially after the examinations, you know, after the board examination results, June, July, result comes. When the result comes, when next day when we go to school, sometimes the headmaster may say, I need all of your IISs, Shreb Salman, yes. I need all of your class results now. How many of them got this much, this much? That means it needs some time. And headmaster may say, I need this within 1 hour. Yes, I need this within 1 hour. We have a class also. So without going to class, If you are doing this work in staff room, you know what will happen to class if teacher is not there. So naturally we'll come to class. Again, even if you are coming to class, if you start doing this work sitting in the chair, you know the condition of IISJ. If the teacher is sitting in this chair and doing some clerical work, if you are let free, then you may start playing not only cricket, volleyball, even football inside the classroom. So to make you engage, what's the best way? For math teachers, it is very easy. Write some 5 questions on the board. Ask your people, come on, boys, solve these questions. So few of you will be busy in solving. Remaining few will be busy in copying. But anyhow, you will be engaged. So we can sit and complete the work. Similarly, one day what happened? This Goss math teacher came to class. He had some work. So to make the students quiet, keep quiet. You know, it is class 4 and class 5 students. So addition. So to make them sit for a while, what he did? He asked the students, okay, boys, do one thing. Add the numbers from 1 to 100. He asked his students to add the numbers from 1 to 100. So he was very sure the students will be sitting with this question for one period so that he can do his work. But contrary to his expectation, what happened? Within few minutes, within a minute or two, this Goss went with the answer. So this is the answer. Without seeing the answer, he said, no, wrong, do it once again. But Goss insisted, no sir, this is the answer, check it. When his math teacher checked it, what the student did, he took it as, yes, this is sum. He wrote this in reverse order. 100, 99, 98, etc. If you're adding 2 times this, 100 plus 1, 101, 99 plus 2, 101, 98 plus 101. He observed it. All these terms were 101. And 101, how many times? 101, 100 times. 101, 100 times is 101 and 2 zeros. That is 2s. Then s is this divided by 2. That gives the sum. So within a minute or two, he got the answer. Actually, that is this formula. How? See here, this AP is A. First time is E. Second term is A plus M minus, no, A plus D. Third term, A plus 2D, etc. Last term, A plus N minus 1 into D. Actually, this story is given in your class 10 textbook. And you may have heard this in class, but you people are least bothered about these things. You will not listen to class. Anyway, writing is in reverse of this is yes. Writing in reverse order, A plus N minus 1 into D. This is A plus N minus 2 into D, etc. A plus N minus 1 is 2A plus N minus 1 into D. Here also A plus A. 2A plus N minus 2 into D plus D is N minus 1 into D is again. Etc. 2A plus N minus 1 into D. He got all the terms as 2A plus N minus 1 into D. All terms are 2A plus. Here all terms are 101. Here all terms are 2A plus N minus 1 into D. So how many terms are here? N terms. Here how many terms were there? 100 terms. So he multiplied by 100. Here we have N terms. So N multiplied 2A plus. This is sum of this. This is 2 times Sn. So our Sn will be N by 2 into 2A plus N minus 1 into D. This is how he got that. Similarly, when you get free time, think about some. Goss was at the age of 10. Now you are 16, 15, 16. So you also in your free time, think about some ideas, invent some formulas. Anything else, we'll continue tomorrow, next class. So these are formulas you are familiar with last year itself. So anything else? We will, yes, you're down. We'll try to make an equation like, yes, that's good, Huzaifa. Yeah, you will try. Yes, see you next class.